This video is over the last part of the algebraic reasoning final exam review. So this is pages 9 through 13. Problem 47 asks us to graph y is less than x plus 4 on the grid below, and then it asks us which coordinate point is a solution for that inequality. So in order to graph this, we would start up at 4 on the y-axis and go up one, right one, a couple of times for the slope of 1. Y would be less than 4, and we would have a dashed line because there's no line under the inequality. So I have a dashed line. And the less than goes underneath. Y is less than the y-intercept, so y is less than 4. For my points, negative 7, 0 is way out here. Negative 1, 3 is on the line. 3, 9 is way up here, and 2, negative 4 is the only one that is very clearly in my shaded area. 49 asks us to factor completely, so we are looking for something that adds up to the middle and multiplies to the outside term. We can put negative 32 divided by x in y equals and look at our factors and see which of them would add up to negative 4. So negative 32 divided by x, looking at my table. So 1 and negative 32 do not add up to negative 4. 2 plus negative 16 is not negative 4. 4 plus negative 8 would be negative 4. So my factors from the calculator are 4 and negative 8. I put them in with x, and I don't do anything else. X plus 4, x minus 8, and that is it. I write my factors exactly like I see them. 49 asked me to factor this one completely. I have a number in front of x squared, so I need to take out the 5. And when I do that, 80 divided by 5 is 16. Now this is a difference of two squares or difference of squares. On the formula chart, a difference of squares, a squared minus b squared, it tells you it's a minus b, a plus b. And remember, we started with squareds and we got rid of the squareds. In order to get rid of the squareds, we take the square root. So the square root of x squared is x. The square root of 16 is 4. So my answer is going to be x plus 4 and x minus 4. Again, that comes from the difference of two squares formula. We just need to get rid of the squared. In order to get rid of the squared, we get to the root of the squared. So we take the square root. The square root of x squared is x. The square root of 16 is 4. Plug them in as we see them. 50 asks us to factor completely, and on this one we're going to solve because we have the equal sign. So the first thing I'm going to do is solve for x. In order to solve for x, is divide by 12 on both sides. So 1728 divided by 12 is 144. So I've gotten rid of the 12, now I still have the squared. To get rid of the squared, again, we take the square root. Whatever we do to one side, we do to the other. So we get down to x because the square root of x squared is x on the left. And the square root of 144 on the right is 12. Remember that square roots can be a positive or a negative. The calculator doesn't tell us that. Our brains have to tell us that. So positive or negative 12, because 12 squared is 144. Negative 12 squared is 144. 51 asks for us to identify the solutions to the following quadratic equations. So the solutions, meaning factor it and take it a step further. So I'm looking for something that adds up to 1y, multiplies to negative 42. So in my calculator, in y equals, I'm going to type negative 42 divided by x and look at the table. Again, I am looking for something that adds up to 1. So 1 plus negative 42 is not 1. 2 plus negative 21 is not 1. 3 plus negative 14 is not 1. I skip 4 and 5 because they are not whole numbers. 6 plus negative 7 is a negative 1, so I can double check. But yeah, I'm looking for something that adds up to a positive 1, so I have to keep going. Now 7 plus negative 6 would add up to a negative 40, or add up to a positive 1 multiplied to a negative 42. So from the calculator, my factors are 7 and negative 6. So I write x plus 7, x minus 6. I write it exactly like I see it. Now for my solutions, I change the signs. X would equal a negative 7 and a positive 6. So factors come straight from the calculator. Solutions are the opposite signs of factors. 52 asks me to solve with the quadratic formula and leave it in radical form. So the radical form is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And by that is my quadratic formula. So I have a is 1, b is negative 5, c is positive 5. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm just going to simplify. Out in front, negative, negative is a positive. On the bottom, 2 times 1 is 2. And in the square root, I'm going to type that in exactly like I see it. Negative 5 minus 1 times 5. Oh, sorry. Negative 5 squared minus 4 times 1 times 5 is 5. So under the radical is 5. And all I've done is reduce. I don't do anything crazy. I don't change anything. 53 asks for us to factor completely. I have something in front, and I need this to be an x squared. Whatever I take out of one, I have to be able to take out of all of them. If I take out a 3 and an x, if I divide it out, x cubed divided by x is x squared. So now I have my normal first term. 24 divided by 3 is 8x, and then the plus 7. So I'm looking for something that adds up to 8, multiplies to 7. Well, multiples of 7 are 1 and 7, and 1 plus 7 would equal 8. So I have the 3x that was in front, and my factors are a positive 1 and a positive 7. So that is as far as I can factor them. Remember that you must put this 3x in front because you took it out. 54 asks how we could express x squared minus 2x plus 1 as a product of two binomials, basically fancy for factoring. Adds up to negative 2, multiplies to 1. So in your calculator, because this one kind of blows our minds, 1 divided by x. Now 0 doesn't work. 1 and 1 are the only whole numbers that we have. Well, how could I take 1 and 1 and get negative 2? Well, if I have negative 1 and negative 1, that would give me a negative 2. So my factors are going to be negative 1 and negative 1, so x minus 1, x minus 1. For problem 55, when I add radicals, I combine my like terms. So I have 3 square roots of 5 and 1 square root of 5 for a total of 4 square roots of 5. I have 6 square roots of 2, and I'm taking away 3 of them for a total of 3 square roots of 2. 56, none of these are like radicals, like square roots, so I need to break them up before I determine that I cannot add them. 72 is 8 and 9. 9 is 3 and 3. 8 is 2 and 4. 4 is 2 and 2. So 4 square roots of 2 from the very front, I haven't done anything with. On this one, I'm going to take out a negative, there's a negative 6 already. I'm taking out a 2 and a 3, and I'm leaving a square root of 2 in the inside. So I have 6 times 2 times 3, which is 36, and it was a minus, so negative 36 square roots of 2. Square root of 50, I have 5 and 10. 10 breaks down into 5 and 2. So there was already an 8 there. I'm also taking out a 5. 8 times 5 is 40. There's a square root of 2 left. In my calculator, I now have square roots of 2, so I can add the numbers in front, leave the square root of 2 as is. So 4 minus 36 plus 40 for a total of 8 square roots of 2. So remember, when you add or subtract, you have to make sure your radicals are like. You have to make them the same before you add or subtract. So with this one, we're going to have to simplify. We have 4 and 12. 4 breaks out into 2 and 2. 12 is 2 and 6, and 2 and 3. So I have 2, 2, and a 3 left. So 2 and 2 makes 4, and I'm leaving the 3. The square root of 12, 2 and 6, 2 and 3. So I'm taking out a 2, leaving in a 3. 4 minus 2 is 2 square roots of 3 total. Anytime I see multiplication, I'm going to put it in my calculator to make sure it won't work out nicely first. So 4 times the square root of 2 times 5 square root of 8. And I get 80. So all I had to do with that one is put it into the calculator. 59, I'm going to see if the square root of 363 simplifies nicely before I do anything, and it does not. So now I have to do it by hand. If you get a decimal, make sure you do it by hand. So 363, I can see a 3 is obviously going to go into it, and 121. 3 I can't break up, but 121 is 11 and 11. So for my final answer, I'm going to have 11 on the outside and a square root of 3 on the inside. For x cubed, we do 3 divided by 2 and get 1.5. 1 goes outside, 0.5 means 1 stays inside. Y squared, 2 divided by 2 is 1, so 1 comes outside. Z can't do anything, so it must stay inside. So my answer is 11xy square root 3xz, all under the square root. 60, I'm going to see if these will work out nicely in my calculator. 25 over 100 in the square root. Math, inner, and voila, it does work out nicely. So I have 1 over 2. For my exponents, x to the 6th is in the top. 6 divided by 2 is 3, and I leave it in the top. Y to the 12 is in the bottom. 12 divided by 2 is 6, and I leave it in the bottom. '61, we type in the square root of 5 divided by 49. Doesn't work out nicely. Math, inner, can't do anything nice. So I might have to rationalize before I go multiplying by the square root of 49. Let me break it up and see if anything else will simplify. Remember, my problem is that I cannot have a square root in the denominator. So let me see if I can simplify the top. The square root of 5 does not work out nicely. The square root of 45, however, equals 7. So I can replace the square root of 49 and only the square root of 49 with 7. Now, because I no longer have a radical, a square root in the bottom, this can be my answer. If there's nothing you can do further, then you have to rationalize the denominator. 61, ask us for the vertex of y equals -2 parentheses x minus 7 squared minus 8. So I can put this into my calculator exactly like I see it and follow my steps to figure out my vertex. I did not bring a graphing calculator home, so you're going to need to look on your steps from Unit 9 to be able to do it in the same way. I will show you how you can plug it into the calculator though. So in the calculator, I have -2 x minus 7 squared minus 8. I plug it in exactly like I see it, and I look at my graph. I can see that my graph is a maximum, so I will click second trace max, go to the left a little bit, press enter, scroll to the right a little bit, press enter, and then come all the way and press enter again, and it will tell you your max is at 7, -8. Now again, if you've memorized the formula or plan to use the formula, your vertex is the opposite of this and the same of this. Again, you don't have to memorize that. You can use the calculator to help you remember that. 62, in order to find the product of this, I will use the box to multiply. 4x minus 2, 6x plus 3. So 4x times 6x is 24x squared. 6x times -2 is -12x. 4x times 3 is 12x. 3 times -2 is -6. Add my diagonals to get 0. So I have a total of 24x squared minus 6. No middle term. 63 says if the quadratic parent function is reflected across the x-axis, shifted down 1 unit and left 3, what would represent the transformed function? So first, my quadratic parent function is y equals x squared. If I reflect it across the x-axis, I'm going to throw a negative in there so I can mark out A. It's going to go down 1 unit, so I'm going to throw in a -1. And being shifted to the left, we're going to have to put in some parentheses here. And going to the left would be a +3. Now, none of my answers look like what I wrote. So what you could do is plug all of those into y equals and see which of them looks like the description that was given. Or you could multiply out what you were given. So if I want to go the calculator route, I'm going to type in -x squared minus 3x minus 11 and graph it. Now this one looks like it was reflected, but it does not look like it only went down 1 and went down a lot. So that's not going to be my answer. So let me try the second one, 6x minus 10. Now this does look like it could have just gone down 1. Yep, and it did. So it's reflected, it went to the left 3, and it went down 1. So that's probably my answer, but let me double check that the one without a middle term is not my answer. Oh yeah, definitely did not go down just 1. So again, if you don't remember how to multiply out, or you don't want to use the box, or you just prefer the calculator, which is totally acceptable, then just make sure that you plug in all of your answer choices to see which of these follows that transformation. We're going to do the same thing on 64. We're going to take all of these and plug them into y equals and see which of these moves 9 units to the right. And that's all we're looking for, 9 units to the right. So the first one, x squared minus 18x plus 81. Now that looks like it went 9 units to the right. Let me check the rest of them. If I change the minus to a plus, it moved to the left. If I get rid of the middle term, it goes way up. We can't even see it on our school calculators. And if I do just a minus, it's going to go way down. So A is my correct answer. 65 says the graph of the function f of x equals x squared minus 7, or in that, which describes the shift in the vertex if -7 is changed to -4. So the only thing happening here is that we're changing the y-intercept, meaning it's going to shift up 3 units. 66 is asking us which of these represents the graph below. So because this one's not multiplied out, you could plug all these in, or we can just figure out. There is no flip. It's not being reflected, so it's not going to be A. This one goes to the left 3, so it would not be D. It goes down 1, so it would not be C. So this is my down 1, left 3, and that's all I really needed. 67, I'm going to label my vertex first. The vertex is at 3, 5. My axis of symmetry is x equals the x point of my vertex. Now this doesn't have a stretch, it doesn't flip or anything, so all we're doing is it moved to the right 3 and went up 5. And remember, if you want to double check your answer, you could plug this into the calculator and make sure you get this graph based on what you wrote. 68, ask me which of these best represents the solution set of 4x plus y is less than or equal to 2. In order to graph, I have to solve for y first. So y is less than or equal to 4x plus 2. So I'm looking for one that starts up at 2. H does not start up at 2. J does not start up at 2. G does not start up at 2. F is the only one that has the correct y-intercept, so that's the only one I need to look at. 69, a compound inequality for -5 is less than or equal to x, which is less than 2. A compound inequality, this is an AND inequality where x is between -5 and 2. So -5 has a filled-in bubble. 2 would have an open circle, and x would be in between there. An OR inequality is where they go in opposite directions. So 4x is greater than 4, and 4 is not included. X is less than -5, and this is the one where we could draw the boat with the person and the two different oars, and he's pushing in between, using those oars for his boat. So AND inequality is where x is in between them, and you have one line connecting them. An OR inequality is this is happening, or this is happening, and they're not joined together.